Wow, this is lovely. Our data have been plotted on the Interpex, and this is it. These are the data points from here now to here. All of them complete 23. And this is the spacing in meter, and this is the apparent resistivity in ohm per meter, and these are the data points based on the resistivity level. This is as high as up to 100. You get here now, it came down, and then here try to go up again. So one thing you should know about this resistivity graph is that this is a log sheet. From here, 1 to 10 is 1, 2, 3, 4, 5, 6. While from here is 10, 20, 30, 100. Same this side. From here is 1 to 10. From here is 10 to 100. And from here is 100 to 1000. Same on the layer model side. The same. Here is the depth, and here is the down is the resistivity. That is, the y-axis is the depth, while the x-axis is the resistivity. Why here on the apparent on the graph side, the y-axis is the apparent resistivity, while the x-axis is the spacing on the ground. The spacing. Okay. Here now, the next thing to do now is to plot our graph. We have entered the points, so we now plot. You go to the layer model. Go here, you see the layer model, estimate layer model. This, not the second one, this. After the question mark, which is a help from Interpex, you pass the estimate smooth model. On the up, you see where my cursor is there. You see where my cursor is up there. After this, you go to the second one here. You now click layer model. Wow. You see our graph just appeared. And then you see the model side as it appeared too, establishing how many layers we have. We'll talk about this in detail. So here now, after this, the next thing to do is what we call iteration. What is iteration? Iteration is plotting the graph to fit the best area of interest, the center of the data point. The basic thing you do as you do in your physics, they will say take the line of what? Best fit. If it is in this we do curve matching. If it is in this in a manual. Here now, the same way you do in curve matching if you have used manual before. So this is multiple iteration. After your graph, after this, you will see it. You see, after the analysis, to analyze equivalent, after the analyze equivalent up there, after the analyze equivalent, you see multiple iteration. You see single iteration. As a beginner, it's good to use a single iteration. At least you'll be able to know how many iterations you did. So that while interpretation, you'll be able to say this data was obtained or this model was obtained with how many iteration you get. Very, very important. So now let me do my first iteration. I'll click. Just click, single click. Wow. You see the single click, you see our graph is taking the line of best fit already. In the single click. It's taking the line of best fit already. It just moved. And if you look down here, you will see our RMS error. You see our RMS error is 13.5. Before we click this, we say we won't even take away this. Before we click this, our RMS error, let me take that out. Let me take that out. Cancel, remove that. I will remove the smooth model. So now, before we enter this, I want us to, let's check and know this. Okay, I just take this out now. I just take the graph out so that we'll know our this thing when we enter this. You see our RMS error, root mean square error here is 21. It's 21 here. I want you to see it very well. You see the RMS error here. It's 21. It's 21. 21.49. I want you to watch this as we iterate so that you will know the change. Okay. So now, as we iterate now, first iteration, the RMS error have reduced to 13.53. 13.53%. If we click again, it have reduced from 13.32. We iterate again, it have reduced from 13.23. We iterate again, the third one, fourth one is 13.03. Keep watching it. I will iterate again, 13.0 at fifth iteration. We iterate again, 12.98 at the sixth iteration. Is stable. 12 is at 12.9 now. So both the RMS error now is now stable, and then the layer model that was moving as we were iterating were also stable. Let me show you the layer model again, because your attention was on the RMS error, so that you know that layer model was moving as we were iterating. Let me take this out. Let me say this. Okay, back again. We just click this, we enter it, we watch the nature. I want you to watch the layer model side now. I want you to watch it. Watch the layer model and its movement as we are iterating. Watch the layer model is on your, you look at the right hand side. You see look up. That is the, I use the look as the operator. Look at the operator. Look at the layer model. As I click single iteration, I go to my lesson and do iteration. I click, you will see the layer model have adjusted. I click again, it's adjusting. As the graph is adjusting, it's also adjusting. You can see how it's adjusting. It's adjusting now. As the graph is adjusting, now the layer model, you iterate until the layer model becomes stable. Look at the layer model is now stable. Okay, now that we have finished our iteration and we're able to get both our graph stable and then our layer model stable, the next thing to do now is to do our simple analysis. The simple analysis we're going to do here now on this interpretation is now to know the resistivity of each layers and the thickness of each layers and the depth of each layers. Resistivity of each layer, the thickness, and then the resistivity. The resistivity, the thickness, and then the depth. Okay, look at it here now. You go up here, you will see two tables. You see a two table here now. The first one is our data, the sounding data, while the second one here we will say edit model. The other one is edit sounding data. No, we are not going to edit our sounding data, but we are going to say edit model. Just click on the edit model, then this table will appear. This table you are seeing here is representing the resistivity model of our interpretation. The table is representing the resistivity model of our interpretation. The resistivity model of interpretation. So look at here, our elevation 91.00 meter, and then you have the fitting error, which is the RMS error is 12.950, and then here you have it in meter. The unit is in meter. Here use depth instead of thickness. That is if you want to use depth instead of thickness. But here the both are here. This is our depth. This is our elevation. You know, elevation decreases with depth. So, and then this is the thickness of each layers, and this is our resistivity in row. See our resistivity in row. Here we are having about 4 layers. Layer 1 is having a resistivity of 85 meter, 85.7 meter, and the thickness is about 0.8, which means layer 1 should be the lateritic soil, the top surface of the earth, about 0.8. Now the depth is still 0.8 and the elevation is 90.115, just minusing 0.85 from 91.00, which is our elevation. So that's our elevation here. So look at the layer 2, which is this layer from here to here. The first layer, if you look at the layer model, is from up here to here. Remember, here is 1. Here is 1. So you look at here, the second layer is from here to here. It started from around 0.8, see, down to here. The depth, the thickness is about 11.416. That's the thickness. And the depth is 12.30 because you have added the top layer. You add this to this, you get the depth. And the elevation have decreased to 78. We are going deeper. Now the third layer, which is this layer that looks small here. This layer here, the third layer, which is this layer, is the thickness, the resistivity is 42.573, while the thickness is 9.2521. That's the thickness. And then 21.530 is the depth, and the elevation is 69.44. You may wonder why as small as this layer look here is far bigger than the first layer. Yeah, that's why I said in the initial stage that this is a log graph. So you can see from here to here is about 10 to 20, while from here is 0.1 to 1. So that's the reason. So here is far longer. The distance and the depth is far more. So here now the third layer, the last layer. We're done with the third layer. The last layer, you will only know the resistivity it starts with. But one thing we don't usually get from the last layer is the resistivity we will get, but the thickness, the depth, and the elevation is usually unknown. The reason why the thickness, the depth, and the elevation of the last layer is at infinity is because the last layer didn't have any reflection back to the surface. We should know what reflection means in resistivity and electricity. So in electricity, you should know what reflection means. And then if there is no reflection back to our machine, it can give you the actual depth of the last layer. It can only give you the resistivity, showing that the resistivity of the last layer is lower than the resistivity of the third layer, because the resistivity of the last layer here is about 10.016. 10.016. If you watch it from the model, you can see it came back, and it was also almost same with the resistivity, very closely to the resistivity of the second layer, which is 8.442. 8.4. And the next thing we are going to do is I want to juxtapose the layer model to our apparent resistivity graph. Yes, I want to put these together to match each of the layer to the curve. I want to match this on the right hand side, the layer model on the right hand side, to our main graph. So what do? We navigate to the top again, and you will look at here, you will see model on data display on and off. So if you click, you're going to on it. That means the model you want to display the model on the data points. So I click this now. Wow, what do you see? You can see that the model is now displaying on the data. You see the first layer here. You see the first layer up here. Then the second layer started from here and then terminated here, while the third layer moved up a bit and here. Now this last layer started from here down to infinity. Remember that here now is serving as both the spacing and also the depth, because what we did was long measure array. So you can believe in me that AB over 2 is equal to depth of penetration. If your spread was 100 meter left and right, you are going to get that at 100 meter depth. So that is it now. See where our data terminated at 100 meter here. You will see the last layer here. So the depth is this way. The resistivity is this way. That is, the depth now is on x-axis, while the resistivity is on the y-axis. Know this, so that you won't be asking me why is the model this way. It's because here now on this graph, you can see the spacing down here. You can see the spacing. So the depth is this way, and the spacing is this way, while the apparent resistivity is on the y-axis. So let me take this off, and then we'll have both our distance side by side. That's for today, and then in our next class, we will be talking about the resistivity of each layers and the rock layer they represent. We will be talking about which rock has such low or high resistivity. So thank you, and always subscribe so that we'll be following our videos back to back.